Hello friends, welcome to Amrita's Blink. Today we are going to look at practice problems on permutation and combination. This is third video from the series. Today we'll see problems based on fundamental principle of counting. In a class there are 27 boys and 14 girls. The teacher wants to select one boy and one girl to represent the class in a function. In how many ways can the teacher make this selection? Now this is a very basic variety of problems which are based on permutation or which are based on selection. Now let's suppose in this problem there are 27 boys and 14 girls. Basically here the teacher has to perform two jobs. The teacher has to select one boy from 27 boys and she also has to select one girl from 14. Now first of these can be performed in 27 ways, that is she can select one boy among 27 boys in 27 ways and one girl from these 14 girls in 14 ways. So by fundamental principle of multiplication, required number of ways are 27 into 14, that is 378. So basically in 378 ways the teacher can make this selection. So the teacher can make this selection of a boy and a girl in 378 ways. How many 3-digit numbers are there with no digits repeated? Now in this problem, first of all we have to understand that we have to make a 3-digit number with distinct digits, that is no digit can be repeated. Now how many digits are there? There are total 10 digits. From 0 to 9 basically there are 10 digits available, but we cannot have 0 at hundreds place. So the hundreds place of these 3-digit number can be filled in 9 ways, that is we can have 1, 2, 3, 4, 5, 6, 7, 8 and 9. So any one of the digit out of these 9 can be placed at hundreds place. So hundreds place can be filled in 9 ways. Now 9 digits are left including 0. So tens place can be filled in. So 8 digits from these 1 to 9 digits, remaining 8 digits, and 0 also we can have at tens place. So tens place can be filled in 9 ways and units place can be filled in 8 ways. So total number of ways will be 9 into 9 into 8, that is 648 ways. How many 4-digit numbers can be formed with the digits 3, 5, 7, 8 and 9 which are greater than 7000 if repetition of digits is not allowed? 4-digit numbers can be formed with the digits 3, 5, 7, 8 and 9 which are greater than 7000 if repetition of digits is not allowed. Now the required number which we want to create is greater than 7000. So the thousands place can be filled in 3 ways, that is we can have either 7 or 8 or 9 at thousands place, because if we place 7 at thousands place, then whatever is the number, let's say 7001, this number is also greater than 7000. So we can fill 7 at thousands place and even 8 and 9. So obviously if we fill 8 and 9 at thousands place, then the number will be greater than 7000. So there are 3 ways of filling the thousands place. Now in this case repetition of digit is not allowed. So out of 5 available digits, hundreds place can be filled with remaining 4 numbers, tens place can be filled with remaining 3 numbers and units place can be filled with just remaining 2 numbers. So total number of ways will be 3 into 4 into 3 into 2, that is 72. So basically we can create 72 such numbers which are greater than 7000 and with no repetition of digits. Three dice are rolled. Find the number of possible outcomes in which at least one die shows 5. Now in this problem, total number of dice which are rolled is equal to 3. So the number of possible outcomes, that is total possible outcomes, are 6 into 6 into 6, which is nothing but 216. Now we need to find out number of possible outcomes in which at least one die shows 5. First of all, we will find out the number of possible outcomes in which 5 does not appear on any of the die. So if 5 is not to be appeared on any of the die, then for all 3 dice, how many choices will be available? Just 5 choices will be available. So number of such possible outcomes are 5 into 5 into 5, that is 125. So easily we can say that required number of outcomes in which at least one die shows 5 is equal to 216 minus 125, which is equal to 91. So we can conclude that there are such 91 possible outcomes in which at least one die shows 5. Find the number of 4-letter words with or without meaning which can be formed out of the letter of the word rose, where the repetition of the letters is not allowed. Find the number of 4-letter words. So basically we need to create 4-letter words with or without meaning which can be formed out of the letters of the word rose. So which are the available letters with us is, there are 4 letters available with us, that is R, O, S and E. And now from these 4 letters we need to create a different 4-letter words. So how many such words are possible, that we need to find out. Now first place of this required 4-letter word can be filled in 4 ways. That is, we can either have R, or we can have O, or we can have S, or we can have E at its first place. Now repetition of the letters is not allowed. So the second place can be filled with remaining 3 letters, third place can be filled with remaining 2 letters, and fourth place can be filled with just remaining 1 letter. So the required number of words will be 4 into 3 into 2 into 1, that is 24. So basically out of the letters R, O, S and E, we can create 24 different 4-letter words. Hence the required number of words will be 24. Given 4 flags of different colors, how many different signals can be generated if a signal requires the use of 2 flags, one below the other? Now, given that 4 flags of different color, suppose we have 4 flags of different colors, let's say like this one, we have one flag, another flag, this is third flag, and this is fourth flag. Out of these 4 flags, how many different signals can be generated if a signal requires the use of 2 flags, one below the other? So the first signal we can create in this way, where there are 2 flags, one below other, and this is, let's suppose, another signal where there are 2 flags, one below another. So the upper vacant place can be filled in 4 different ways. So the first upper part of the first flag can be filled in 4 different ways. So following which this lower part can be filled in three different ways. Hence, by multiplication principle, required number of signals can be 4 into 3, that is 12. How many 2-digit even numbers can be formed from the digits 1, 2, 3, 4 and 5 if the digits can be repeated? Now in this problem it is a bit different. Here we can repeat the digits. Now how many digits are available with us? We have 5 digits, that is 1, 2, 3, 4 and 5. And out of these 5 digits we need to create 2-digit even numbers. So the units place, now how do we identify even number? Is the number which have either 0, 2, 4, 6 or 8 at their units place is called as an even number. So out of these 5 digits, given 5 digits 1, 2, 3, 4 and 5, if we can place this 2 and this 4 at the units place, then the number which will be created will be an even number. So we can say that the units place of the required numbers can be filled in two different ways. Now out of the 5, now here repetition of digit is allowed. So remaining tens place can be filled with any of the 5 digits. So we can say that this tens place can be filled in 5 ways. Hence the required numbers will be 2 into 5, that is equal to 10. So we can say that out of 1, 2, 3, 4 and 5 we can create 10 different 2-digit even numbers when repetition of digits is allowed. Find the number of different signals that can be generated by arranging at least 2 flags in order, one below the other, on a vertical staff in 5 different flags are available. If 5 different flags are available. Now a signal can consist of either 2 flags, 3 flags, 4 flags or 5 flags. See, find the number of different signals that can be generated by arranging at least 2 flags out of 5 different flags available. So maximum flags available are 5 and we need to take at least 2 at a time. So a signal can consist of either 2 flags, 3 flags, 4 flags or 5 flags. Here at least 2 flags are to be there out of 5 flags. So there will be 4 cases, that is we can have either 2 flags signal or 3 flags in the signal or 4 flags in the signal or 5 flags in the signal. Now let's suppose if there are 2 flags in the signal out of 5, then such 2 flag signal can be created in 5 into 4, that is 20 ways. Now let's suppose there are 3 flags in the signal. Then such signals are created in 5 into 4 into 3, that is 60 ways. Now let's suppose there are 4 flags in the signal, then such signals can be created into 5 into 4 into 3 into 2, that is 120 ways, and all 5 flags, if all 5 flags are to be used in the signal, then different ways can be 5 into 4 into 3 into 2 into 1, that is 120 ways. So in all, total number of signals can be 20 plus 60 plus 120 plus 120, that is 320 ways. How many 3-digit numbers can be formed from the digits 1, 2, 3, 4 and 5, assuming that repetition of the digits is allowed and repetition of the digit is not allowed? Now how many digits are given? There are total 5 digits available with us, that is 1, 2, 3, 4 and 5. So let's consider the first case where repetition of digits is allowed. Now we need to create a 3-digit number. So the units place of, let's say, this 3-digit number can be filled by any of the number out of these available 5 digits, that is in 5 ways. Similarly, now when the repetition of digit is allowed, so tens place can also be filled in 5 ways and hundreds place can also be filled in 5 ways. So the required total numbers of 3-digit numbers where repetition is allowed will be 5 into 5 into 5, that is 125. Now let's consider the second case where repetition of the digit is not allowed. Now here also there are 5 options available with us, 1, 2, 3, 4 and 5. So let's say if we fill units place can be with these 5 numbers, so units place can be filled with 5 ways. So the remaining tens place can be filled with remaining 4 digits and hundreds place can be filled with remaining 3 digits. So total number of ways will be 5 into 4 into 3, that is 60. So if the repetition of digit is allowed, then out of 1, 2, 3, 4, 5, these 5 digits, we can create 125 numbers. But if repetition is not allowed, then we will be able to create only 60 numbers. How many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5 and 6 if the digits can be repeated? Now there are 6 digits available with us, that is 1, 2, 3, 4, 5 and 6. Now here also we need to create 3-digit number, but one more condition here is added, is we need to create 3-digit even numbers. So we have already seen the definition of even number, that is if the number is having 0, 2, 4, 6 or 8 at its units place, then the number created will be a even number. Now out of these 5 digits, which digits are available, that is 2, 4 and 6. So out of these 6 available digits, if we place 2, 4 or 6 at units place, then the number created will be an even number. So we can say that the units place of these numbers can be filled in 3 different ways. Now repetition of digit is allowed in this case. So the tens place can be filled in 6 ways and even hundreds place can also be filled in 6 ways. So the required numbers will be 3 into 6 into 6, that is 108. So ultimately out of these 6 digits 1, 2, 3, 4, 5 and 6, we can create 108 3-digit even numbers. How many 4-letter code can be formed using the first 10 letters of English alphabet if no letter can be repeated? Now we need to create a 4-letter code out of first 10 letters of English alphabet. So let's say first place, that is let's say units place, can be filled in any of the 10 letters. So it can be filled in 10 ways. Now no letter can be repeated. So the second last place, so just for the sake of convenience we will call it as a tens place, but actually it is a second last place, can be filled with 9 alphabets. Third last place, that is hundreds place, can be filled with 8 ways, and thousands place, that is fourth place, can be filled in 7 ways. So the total number of 4-letter code will be 7 into 8 into 9 into 10, that is 5040, 5040. So we can create 5040 4-letter codes out of first 10 letters of English alphabet when repetition is not allowed. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 67 and no digit appears more than once? Now here what we need to create is, we need to create a 5-digit telephone number, but this 5-digit telephone number should always start with 67. So let's suppose there are 5 places, that is, this is units place, this is tens place, this is hundreds place, this is 1000s place, and this is 10,000s place. So this 10,000s place is always filled in only one digit, that is 6, and this 10,000s place can always occupied by 6, and 1000s place can be occupied by only 7. So we just have to fill remaining 3 places, that is 100, 10 and 1. And to fill these 3 places, how many digits are available? That is 0 to 9 digits are available, but no digit appear more than once when 6 and 7 are already utilized. So out of these 10 digits available, 6 and 7 are utilized, so we can just have 8 options to fill up the hundreds place, then 7 options to fill up the tens place, and 6 options to fill up the ones place. So total number of ways will be 8 into 7 into 6, that is 336. So we can say that we can create such 336 numbers which should start with 67. A coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there? Now, a coin is tossed three times. You just have one coin, but the coin is tossed 3 times. Now, the possible number of outcomes when one coin is tossed are just 2. That is, you can either have head or you can either have tail. So the possible number of outcomes when the same coin is tossed second time is again head or tail, that is 2. When the same coin is tossed for third time, there also possible number of outcomes are just 2, that is head or tail. So total number of outcomes are 2 into 2 into 2, that is nothing but 8. Given 5 flags of different colors, how many different signals can be generated if each signal requires the use of 2 flags, one below the other? Now here the upper place of the flag can be filled in 5 ways by using the 5 flags of different colors. Now the lower place of the flag can be filled in remaining 4 ways by using the remaining 4 flags of different colors. So the total number of signals will be 5 into 4, that is 20. So in this video we have seen some problems based on fundamental principles of counting. Thank you. In next video we will see few more problems on permutation.